Welcome back, everyone. Today, we are going to be talking about determining the minimum and maximum values of a quadratic equation. And we're going to talk about doing that in a whole bunch of different ways, not just if we have a vertex form equation. One thing I want to mention first is that when it comes to finding the minimum or maximum values, there's two important things. Is that the k value is the actual minimum or maximum value. So when we do have a vertex form equation, we automatically know the answer. We know, oh, it's the k value, and that's it. You're done, right? However, how we're going to learn today about how can we actually make something that is not in that form to be that form, or how can we find, or what's another method of, in some cases, finding that k value, that minimum or maximum value, without actually going to vertex form. So we'll discuss all of that today. Also, you might wonder, well, how do we know whether there's a minimum or a maximum, and can there be both? Well, if you picture a quadratic or a parabola, no, there can't be both. Every quadratic either has a minimum value or a maximum value, but not both, right? If the parabola opens up, right, then we have a minimum value. We have it starting low down, or at some point, doesn't have to be low down, but at some point, and going up, right? So therefore, there's a minimum value. Now, if the parabola opens down, it's the opposite. We have a maximum value, and every other point is below it. So either we have a minimum or a maximum, depending if it opens up or down, right? So basically, if the a value, so that very first number in front of our quadratic after the y equals sign, if it's positive, that means that it opens up and we have a minimum. And if it's negative, that means it opens down and we have a maximum. So that's how to know, is our min/max value, like, which one is it? Because sometimes you'll be asked that too. You won't just be asked to find the optimal value or the min or max value. You'll be asked, which one are you finding? Is it a minimum value that you're telling us, or is it a maximum value that you're giving us, right? So let's get into it. Let's do that. So it does mention here there's two ways to find the minimum or maximum value of a quadratic. We're going to get into the first one, which is examining a quadratic equation in vertex form. Often completing the square is required. So completing the square, that's the method to change something from standard form into vertex form. So sometimes it's not obvious where the vertex is, but by changing the equation into a vertex form equation, we're able to get there. So let's do it. Let's start with this example where it says graph this equation and find the minimum or maximum value and where it occurs. So for example, for this one, we know that our h comma k is 3 comma negative 4. So therefore, that's right here. And we're just going to do our regular over 1 up 1 over 2 up 4 pattern. Oh, and if you're unfamiliar with the graphing this, there is an entire video on that, so go check that out if you haven't already. It's lesson 2 in the series 1, if you're interested in that. Okay, so let's draw our parabola like that, and we can tell from the graph and also from just this equation that the minimum or maximum value, in this case it is a minimum value clearly because it opens up, and our a value is positive here, right? I don't see a negative sign. So therefore our minimum value is y equals to negative 4, right? That's our k value, so our y coordinate of the vertex. And it occurs, so it always occurs at the x coordinate of the vertex, or axis of symmetry, which in this case is 3. So, and it occurs at x equals to 3. Very good. Oh, and as always, if you have questions about any of this, drop me a comment, please, and thank you. I'd appreciate that very much. Okay. For the equation, y equals x squared plus 8x plus 13, complete the square to find the minimum or maximum value and where it occurs. Okay, so for this one, it says to complete the square, and we haven't really done that yet in this course, at least. I haven't explained before how to do this. So before we actually get into the question, I'm going to explain what are the steps to completing the square. So step one is that if there is a leading coefficient, factor it out of the first two terms. Now, in this case, there is no leading coefficient, well, other than 1, so we actually can skip this step. So we won't actually do this time, but I did want to put it as one of the steps because it is crucial if there is a leading coefficient and to check for that first. So in this case, don't worry about it. Sometimes it'll occur, though. Okay, number 2. Step 2 is to find the b over 2 squared value. Okay, so what do I mean by the b over 2 squared value? Well, you know how every equation we have y equals ax squared plus bx plus c. So b is the coefficient of our x. So in this case, it's 8. So we would find 8 over 2 and then square that value. So we would find what that is. So let's do that. Let's do it as I explain the steps. So 8 over 2 squared is 4 squared, which is 16. So we did step 2, we found it. Very good. Number 3 is to add and subtract. Add and subtract the result. And what I mean by result, I'm going to be more clear, the b over 2 squared value. In the equation. Okay, so our original equation is y equals x squared plus 8x plus 13. What if I add 16 and subtract 16? So I'm going to do that. X squared plus 8x plus 16 minus 16 and then plus 13. Okay, so what you'll notice is I didn't actually change the equation. I just added 0. Plus 16 minus 16, well, I could cancel that out. We could get 0 right now. We could go back to the original equation. Now, we're not going to do that because that would defeat the purpose of all these steps we're taking, but my point is we could, right? We could. We're not actually changing our equation, we're just changing the form of the equation here, which is our goal, right? We don't want to find the min or max for a different parabola. We want to find it for this one, but we need to change the form to do that. So I did want to point out that our equation doesn't actually change here, just the format of the equation changes here. That's all that changes. Okay, and let's do step 4, which is factor the first 3 terms and collect like terms, which I guess is 2 things, so we can kind of do it all in one. Okay, so factor the first 3 terms. So the thing is, there's always a specific way to factor these first 3 terms because they're always going to be that perfect square method of factoring, right? Recall that a plus b squared is equal to a squared plus 2ab plus b squared, right? So it's always going to be this pattern every single time. That's why we found the b over 2 squared value, was so that we could guarantee that every time it will follow this pattern. So not only do we factor the first 3 terms, we always factor them using this. So I'm going to do that. X plus 4 squared is factoring the first 3 terms. And then when I say collect like terms, I just mean the negative 16 and the 13. We can collect those and just get negative 3 at the end there. So negative 3 is there. So therefore, what did we learn from this? We completed the square. We now know that the maximum or minimum value, in this case the minimum value, because we have a positive sign here, right? We have a positive leading coefficient for our a, so we know that therefore it is a minimum. That therefore the minimum value is our k value, right? So y equals -3, and it occurs at x equals to -4, right? And you might wonder, and a common question I get asked a lot of the times from students is, how come it's -4? I see a +4. And that's true, but keep in mind that our original factored form equation, sorry, not factored form, vertex form equation looks like this. It's y equals x minus h squared plus k, right, with the a in front as well, possibly, right? We possibly have an a value that isn't 1 necessarily. So in this case here, we have a negative there, right? So if we have a positive here, then the h value itself is actually negative, right? Because we would have negative and then a second negative inside the h that would make it positive. Whereas, let's say it's negative, let's say it's x minus 3, for example, in here. Well, then it would be +3 because the negative is not part of the 3, right? The negative is just part of the equation, right? So that's one way to think of it, is that there's always a negative there. Another way you could think of it is just that it's always the opposite of what you would imagine that it is. So that's something I get asked a lot. So I thought I would mention that here. But as always, if you do have any questions, leave those down in the comments. I do check the comments. Okay, let's move on to another one. For the equation y equals 3x squared minus 12x plus 24, complete the square to find the minimum and maximum value and where it occurs. Now, normally it's at this point that I would encourage you to pause the video and try it for yourself, and you can if you'd like to. This one is different enough though that if you don't want to do that, that's perfectly valid as well, because there is an extra step here, which is step 1 that we didn't do before. If we recall, step 1 was if there is a leading coefficient, factor it out of the first 2 terms, and I didn't have to do that last time, and this time I need to do that. So let's do it. Y equals 3x. Oh no, sorry, just the leading coefficient. 3x squared minus 4x plus 24. So all I've done here is just factored out that 3. Okay, then the next step is to take that b value, which in this case we're going to imagine the b value is just this 4, right? That just this -4, and doesn't have to be multiplied by the 3. So keep that in mind too. Even though technically the b value is -12, we're going to pretend as though it's -4 because that's what's actually in our brackets. We factored out the 3. So let's do that. -4 over 2 squared is equal to -2 squared, which is equal to 4. So we're going to add and subtract 4 in those brackets. So this is equal to 3x squared minus 4x plus 4 minus 4 plus 24. Then our next step is we're going to factor the first 3 terms. So we're going to factor these terms. And then this term, something very important I want to mention about the -4, a lot of people will just remove it from the brackets and put it out here. But we can't do that. In order for the -4 to leave the brackets, it must be multiplied by this 3 in order to do that. So we're actually going to have 3 times x minus 2 squared, right, to factor, to follow that pattern that I talked about earlier. Then we're going to have 3 times -4, which is -12, and then plus 24 tacked on the end. A common mistake I see is just -4 plus 24. No, always make sure that when you factor something out for the leading coefficient, that -4, whatever that number is, gets multiplied before it leaves. That's its exit pass, if you will, for it to leave. Okay, so then our answer is 3 times x minus 2 squared plus 12. So therefore, our minimum value, or the minimum value, is 12, and it occurs at x equals 2. And just a reminder, that's 2 and not -2 because the negative is part of the equation, so it's only the 2 that's the actual h value. So therefore, it is indeed +2. That was not a typo. All right, very good. Very, very good. This next one is very similar. I mean, they gave it in word problem form, but in terms of the actual method of solving, it's the exact same as the last ones that we just did. So let's do it. It says if a flight of a flying squirrel is given by this equation, where the time in seconds and the h is in meters, the height is in meters, find the maximum height of the squirrel and the time that it occurs. So this time they did kind of give away that it's maximum height, but at the same time, maybe it didn't take a lot for us to know that, right? We see right here that a is a negative value, so it must be the maximum height. And also too, the flying squirrel is flying everywhere or an airplane's flying or whatever it is, minimum height wouldn't make a lot of sense, right? Because technically minimum height of anything like that you would think is zero, right? That it's not flying at all is the minimum, whereas maximum, that could vary, right? Maybe this flying squirrel can fly higher than I can, but not higher than the airplane or the bird, for example, right? I don't know, but that's just a guess, right? Different animals or different structures or whatever it is, they can be higher. They can have a maximum height that's higher than other things. Whereas minimum height, usually that's just the ground, unless we're digging underground for some reason. Good. So let's do it. Let's use the same method as before to figure this out. So first things first, I'm just going to rewrite the equation that they have given us here. Then I'm going to do step one from earlier, which was to factor out the leading coefficient. So let's do that. Negative 0.5 x squared minus 12, we'll say, or 12x rather, minus 11. Then I will do 12 over 2 squared, right, our b over 2 squared value, and get 6 squared, which is 36. So this is step 2. Step 3 is to go back here and to add and subtract that inside our brackets. X squared minus 12x plus 36 minus 36 minus 11. And remembering that this minus 36 needs to be multiplied by the 0.5 for it to leave the brackets. So then we're going to do step 4, which is to collect like terms and also to to factor the first 3 terms in our brackets. So we still have negative 0.5 out here. Then we have x minus 6 squared. And then we have minus 11, and we also have 36, or minus 36 rather, times negative 0.5, which is plus 18. And then I guess this is still step 4 because I didn't actually combine like terms. I just wrote out what the like terms are that we need to combine. So I'm going to do another step for step 4 and actually combine them and get 7. Good. So therefore, the maximum height is 7 meters, and it occurs after 6, positive 6 by the way, seconds. And there's our answer. Very good. So far we've only really done one method of finding the minimum or maximum value. Basically, we have either had something in vertex form, we've just quickly glanced at it and known the answer, or we have put something that is in standard form into vertex form in order to manipulate it to do what we want it to do and to give us the information that we would like to know about it. However, we haven't talked about what's the second method, right? I mentioned there were 2 methods, so what's the second method we could do that? The second method is if we have something in factored form, or if we're willing to factor, we are able to figure it out that way. Okay, so here it asks for the equation negative 2x squared plus 4x plus 16, use factoring to find the x-intercepts and use the vertex to find the minimum and maximum value and where it occurs. So in this case, we can actually find the zeros, right? We already talked about finding the zeros using the zero product property whenever we have zeros that are available. But what I didn't mention there is that if you take the average of the zeros, so assuming there are zeros, that exists, which not all quadratics have zeros, but let's say a quadratic does. Every quadratic that does have zeros, we always take the average of those zeros, and we can get the axis of symmetry, which is also the x-coordinate of the vertex, and we can then plug in that value to the original equation to find the y-coordinate of the vertex, which also is the minimum or maximum value. So that's another way we can do it. So for questions like this, step one is to fully factor. Step two is to find the zeros. And this would be using the zero product property. In the very first video ever in the series, we talk about using the zero product property. So if you're not familiar with that, go check that out. Number three, after we find the zeros, is to find the average of the zeros. So find H, right, which is the average of the zeros. And there's only ever two zeros, or 1 0 technically is possible too. So this is also the average of zeros and axis of symmetry. And then number four is to sub H. Sub H equals, does not equals, sub H equals to X to find, or I guess I should say X equals H to find the min or max value, right? To find that K value. Okay. So that's the goal here, right? So I'm going to talk one more time about, well, why would this method work? And also, when would this method not work? Because this method does not always work. The other method I actually prefer, even though it's, maybe a bit more tedious, because it does always guaranteed work. So this one works because whenever we have two zeros, or really any 2 points that are equidistant on our quadratic, right? We're able to take that information, find the average of those x values, and that gives us our axis of symmetry. And the zeros are no exception. If we find that, we find the x coordinate of the vertex, and then from there we can easily find the y coordinate of the vertex moving forward, right? So that's pretty straightforward, which is really nice. Okay. So given that, and also I should mention, when does this not work? So this does not work for quadratics that don't have any zeros. So if a quadratic is not factorable at all, or it does not have any zeros, this does not work. So whenever you see an equation already in factored form, you know for sure that this would work because it can be factored if it's already in factored form. However, if it's in standard form like this one, we don't always know. Right? What if I couldn't factor this? How do I use this method? Well, I can't use this method. I have to use the other method if I would like to find my min or max value. Right? And this goes back to the idea too that all quadratics always have a vertex form and always have a standard form, because every quadratic does have a y-intercept and every quadratic does have a vertex. But not every quadratic has a 0 or x-intercept, and therefore factored form is not a possible form for all quadratics. There are some quadratics that have no factored form, and those are the quadratics that do not have any solutions, x-intercepts, zeros, whatever you like to call them, right? By the way, x-intercepts, zeros, and solutions all mean the same thing. Okay. So let's get on to actually doing it. Let's stop stalling here. Y is equal to, it's common factor first, x squared minus 2x minus 8, which is equal to, let's see, well, what are two things that multiply to negative 8 and add up to negative 2? Let's see. Maybe 4 and 2. Oh, yeah, that works. That sounds good. Negative 4 times 2, and then negative 4 plus 2. That will work. So x minus 4, x plus 2. Good. Okay, so now we have to find the zeros. All of this was step 1. Step 2 is to find the zeros, so that's going to be x is 4 and x equals negative 2. And I'll briefly explain how I got those numbers. Basically, when we're finding the zeros, we know that if anything we're multiplying together with anything else is 0, the whole thing is 0, right? If I have negative 2 times 0 times a bunch of other stuff, it's all just 0, right? As soon as we multiply a 0 or into our equation, the whole thing is 0. It ruins the whole thing, or makes the whole thing how we want it, in other words, right? Depending on how we look at it. And so in this case, I chose 4 and -2 for the zeros, because if we plug in 4 to this equation, we get 4 minus 4 as one of the things we're multiplying, and that's 0. And 0 times -2 times whatever the other bracket is just 0. And likewise, for our third bracket here, if I plug in -2, we just get -2 plus 2, which is 0. 0 times the other stuff, I don't even care what the other stuff is just 0. Right? So again, if that's a concept that's confusing, do watch the very first video of the series where we talk about the zero product property, because that's all I'm going to say on it for this video specifically. Let's try number 3, which is find h, which is the average of these zeros. So 3, h is equal to 4 plus -2 divided by 2, which is 2 over 2, which is 1. Right? So 1. Then we need to find k. We need to sub x equals h, or in this case, sub x equals 1, right? Because h is equal to 1, we just found it. Y equals -2 times 1 squared plus 4 times 1 plus 16, which is equal to -2 plus 4 plus 16, which is equal to 18. So our y value is 18, or I guess we could even call this our k value, right? We could say this is k, our minimum or maximum. Now in this case, it must be a maximum because the parabola opens down, right? We have a negative sign in front, so that means it must be a maximum. So therefore, the max value is 18. And it occurs at x equals to 1. Good. All right, let's do another one like this. Here it says for this equation, y equals 2x squared plus 4x minus 30. Use factoring to find the x-intercepts, and then use the vertex to find the min and max value and where it occurs. And this is our last question for today, so if you're getting tired, don't worry. This is our last one. I encourage you to pause the video, give this a try if you're comfortable doing that, and then come on back when you're ready to have this taken up. All right, so it's been possibly some time, possibly no time at all, but let's get into it. So y is equal to 2 x squared plus 2x minus 15 is my first step. My second step is to factor this and say what are two things that multiply to -15 but add up to 2. And those are, of course, -5 and +5 and -3, right? So y equals 2 times x minus 3, x plus 5. So to find the zeros, this is step 1. Find the zeros is step 2. X is 3 and x is -5. Step 3 is to find the h value, right? So to find the average of those two zeros, so that's going to be 3 minus 5 over 2, which is -2 over 2, which is -1. Then sub x equals 2, h, which is -1 in this case. So y equals 2 -1 squared plus 4 -1 minus 30. Or we could even say k is equal to this. Let's do that actually. I like that better. So k is equal to 2 minus 4 minus 30, which is -32. And in this case, we have a positive leading coefficient. It's +2. So therefore, it's a minimum value, not a maximum value. So therefore, the min value is -32, and it occurs at x equals to -1. Okay, so that's everything for today. If you do have any questions, please leave them down in the comments, and we'll see you next day. Bye.